Hi everyone, this is Jay, the Laboratory Director of Nootropics Depot and Omniant Labs. I would like to spend a few minutes today and talk about a response to a post that was made on our subreddit about the reduction of NMN to reduced NMN. And in order to do that, I'm going to have to use some new technology. So we have a neat microphone and a sweet camera and a dry erase board that we'll be using. And we're going to learn a little chemistry, so sit tight. Hopefully I won't be too annoying, but I'll try to explain what I think is going on here and why I think what I do about this Reddit post. So that said, let's hit the board and draw some chemistry. Okay, so before we get started in the reduction of NMN, we need to talk a little bit about what is redox and what is oxidation reduction chemistry. So, redox. Redox stands for reduction and oxidation. In our example, in this Reddit post that I'm referring to, the redox reaction that was stated was using magnesium metal. They use magnesium ribbon, magnesium powder, magnesium metal, magnesium with a zero charge. That's what the little zero here means. What I'm going to write is what's called a half reaction, which is what magnesium does in the presence of redox chemistry. So magnesium metal with no charge becomes magnesium ion with a +2 charge, and the two electrons are written 2e- for electrons. They have to go somewhere. This is called a half reaction. So when you add magnesium metal to water, magnesium metal plus water gives you the chemical reaction of magnesium hydroxide produced and hydrogen, which is a gas, which is bubbled. And just like the Redditor said, he observed, or she observed, hydrogen gas being produced, and so he or she believes that this reaction did occur, and to be honest, I agree with that. I don't see a problem with this. Now, if we want to balance the chemical reaction so that all the atoms are accounted for, we have to put 2 in front of our water. I don't know if you guys care about that or not. As a chemist, I do, because that's just what I do. So before we can get into the NMN stuff, we have to do a little bit of organic chemistry. So I'm going to erase this and go through the organic chemistry side of it. This is the inorganic chemistry side that we just discussed. This is NMN. This is the structure of NMN. To make it easier to draw over and over again, I'm not going to draw this part, which does not take place in the oxidation reduction chemistry. I'm just going to draw the bottom part, and I'm just going to draw a little wavy line right here to represent the rest of the molecule. So from now on, you'll see me draw NMN like this. And in this particular case, I'm drawing reduced NMN, also called NMNH. So what I can do now is draw the wavy line and include the correct charges. Right. So what the Redditor is claiming is that this is the chemical reaction that he did in the presence of water and magnesium. I don't think this actually happened, and I'd like to spend the rest of this video explaining why. In this reaction, what you need to do is add a hydride to this carbon. Now, for those of you that are not chemistry people, a hydride is actually H-. You've heard of hydrogen, which is H neutral, 1 proton, 1 electron. You've heard of the hydrogen atom, which is H+, also called a proton. But hydride is a term that non-chemists probably not have heard about. It's a hydrogen with a negative charge. It is an extremely basic, extremely unstable compound because it's pretty much the most basic thing you can have, hydrogen with a negative charge. In order to create this reaction, you have to provide a hydride, H-, to this carbon. Specifically, you need to add 1 right there. Right, we already have 1, we want to add another. This is what we need to do that. Now that's actually possible in organic chemistry, and there are ways to provide hydride to organic molecules. So for example, a very common one is called sodium borohydride, NaBH4. Note the name is called borohydride because the hydride is in the name. What sodium borohydride looks like is this: sodium with a positive charge, and then boron with 4 bonds, which it doesn't like, anhydride and a negative charge. So it exists as a salt. Sodium borohydride is a hydride donor. It gives away one hydride because it doesn't like to be hydride-aided. So an example reaction, if you take something like acetone, and in the presence of sodium borohydride, and then after the reaction is complete, you add water, you can generate something like isopropyl alcohol. This is a very common organic chemistry mechanism. The way this works is the hydride from the boride ion attacks this carbon, the electrons go up, your boron becomes BH3 and floats away, and your hydride makes a bond to this carbon, so you get a carbon-hydrogen bond right there. Then in the second step, when you add water, the electrons on the oxygen get protonated by the water and leave you with your isopropyl alcohol, and technically you have OH minus floating around as well, right? This is common organic chemistry, sophomore level organic chemistry, happens all the time. The key takeaway here is that you need a hydride donor. In this case, sodium borohydride. Other examples, lithium aluminum hydride is another one. It's the same thing. It's a lithium ion and an aluminum hydride ion with a negative charge, which makes it unstable. It doesn't like that. These are both hydride donors. So this is how it works in organic chemistry. So if we want to reduce NMN to reduced NMN, as was proposed in the YouTube or in the Reddit post, we need to do the same thing. So here is our shorthand for NMN. Here's our structure for reduced NMN. Again, shorthand, so I don't have to draw the rest of the molecule, NMNH. And we have to do the same thing. We need a hydride source that will attack this carbon. The electrons will then move around the ring so that this double bond is the same, and this double bond moves to this position, and now we have an extra hydrogen at this carbon. And I didn't draw it before, but there it is. All right, that's what we need to do. This Redditor claims to have done this reaction using magnesium, specifically magnesium metal. This is the problem. Magnesium metal, if you remember from before, can give you 2 electrons, but these 2 electrons do not have a source of hydride. These 2 electrons are not the same as these 2 electrons. I'm just going to clean this up. Right? As soon as you add magnesium metal to water, these 2 electrons go to the oxygen in the water, and they give you hydrogen gas and magnesium hydroxide. So these are the products you get when you add magnesium metal to water. You don't get hydride. So there's no hydride being generated in this reaction. Now the Redditor claims that there was a yellow color that was formed and that NMNH, or reduced NMN, is yellow. Maybe that's true, maybe it's not, I'm not really sure, to be honest. And that the color is what was indicative that this reaction was happening. Well, color is not really the appropriate way to judge whether or not this particular reaction happened. Did a reaction happen? Yes, this reaction absolutely happened. In fact, the Redditor itself admitted that H2 gas was given off. That seems pretty obvious. In fact, I think that's the majority of the chemistry that was happening here. However, at no point in any of the chemistry involved was hydride generated. Hydride is extremely basic. If you have hydride in the presence of water, immediately, extremely fast, maybe one of the fastest reactions that exists, hydrogen gas and OH minus. And that's because this hydrogen will immediately bond with one of these hydrogens, leaving as a form of hydrogen gas, and the remaining OH group will just float away as hydroxide. So I don't think this reaction happened because there's no source of hydride, and the reaction of magnesium being oxidized to magnesium ion and therefore reducing water from water to OH and creating H2 gas is likely all that happened. The yellow color, truth be told, I can't exactly explain, but there are a lot of ions in solution. There could be other organic molecules that were present. I don't know where the NMN came from. It likely is not 100.00% pure NMN, so there could have been other organic molecules that maybe got oxidized or reduced in this process. There's lots of unknowns about this because, again, it's just a Reddit post, so not all the details are known. But by and large, given the information that we do have, the addition of magnesium metal to water will do this reaction way faster, hundreds of thousands, if not millions of times faster than this reaction. And I would argue this reaction can't even happen because there's no source of hydride. So for that reason, I think that this reaction did not actually happen. And unfortunately, NMN or reduced NMN was not generated by this Redditor, at least per this Reddit post. Thank you.